Hello, in this video lecture I will explain example 5.2, the problem of critical path method. If you read this case, the point of this project is to design, develop, and produce a prototype of the small computer. The first charge of this project team is to develop a project network chart, and it determines approximately if the prototype computer can be completed within the 35-week target, or approximately 8 months, to produce the prototype. So this is estimated the time duration can take longer or shorter. Now we have to identify the activities of the project. So major components of the project include the design of the computer, prototype construction or testing, and writing the equipment report, method report, and final report. And you identify the time duration of each activity. Now you have to, find out immediate predecessors based on the discussion of the project manager and the members. So we call activity sequencing. So make sure that each activities are in the proper order, and the logic of their relationship is maintained. For example, it would be illogical to have a situation where activity A, which is the designing of the computer, precede activity B, which is the building the prototype, or B precede C, or C precede A. This kind of situation is illogical, so make sure that all the activities are following the preceding relationships. Then you draw the network diagram based on these preceding relationships. So activity A and BC, you can change this order, that's fine. And D has, followed by B, and EF as the CD has the, CDs are immediate predecessors. Finally, the last activity G, followed by E and F. Once you draw this network diagram, you can identify what are the critical paths, how many paths we have, and what are the critical paths. So this network has the 4 different paths, as you see here. A, C, F, G, which takes 8 weeks, and A, C, E, G, 35 weeks. A, B, D, F, G, 38 weeks. A, B, D, E, G, 35 weeks. So as you may notice, there are two same longest paths, which is two same critical paths. So critical path 1, A, C, F, G, 38 weeks. Critical path 2, A, B, D, F, G, 38 weeks. As I said, it is possible to have multiple critical paths. So you may notice that this project has two different critical paths, which might indicate that this would be a fairly difficult project to manage, because critical paths should be tightly managed. If you delay the critical path, you will delay the entire project. Let's look at the early start finish, late start finish time to find out and calculate slack time. Start with activity A. So for the path, we calculate early start finish time 0, 21, and 21 goes to C and B, and 28. This is early finish time. Then now activity D has only one predecessor, so 26 goes to early start time of D and 28. Now we have F has two predecessors, C and D, but the early finish time of two activities are the same, no conflicting, so goes to the 28. Here is the activity is the same, two predecessors but no conflicting, so 28 goes to here, and 36 and 33. But here you see the two different predecessors active early finish time. They are different. They are conflicting. So we choose the maximum or largest number. Goes to the your largest activity. Last activity G. That's the early start time of activity G. And 38 is your early finish time of activity G. You see that 38 is the critical path, which is the last activity's early finish time. That's the time duration of the entire project. Now we use the backward path to calculate late start and late finish time. We set to 38 in order not to delay the project. 36. So 38 minus 2 is 36. And this goes to E and F early finish time. We set by 36 so that we do not want to delay the project. So we start right away activity G. 36, and minus 8, 5, so 28 and 31. Go to look at the activity D. We have two different, activities to follow, but these are conflicting. So which one we choose, 28 or 31? We choose the minimum number of or smallest number of the activities to follow. So 28 go to your late finish time for activity D, and 26. Again, activity C has the 28, 31. You choose the 28, 21. Now activity B, we have only one activity to follow. So 26 goes to last late finish time for B, and 21. Now we have 21, same late start time activities, no conflicting, goes to 21 and then 0. Now we have to find out which activities have slack time, meaning which activities has 0, which activities are not on the critical path, which activities have same early start and early finish time, late finish time. Early start and late start time. Only E, right? And other activities are all the same. 0, 0, 21, 21, 21, 26, 28, 36, except E. How much slack for activity E? 3 weeks slack, because 31 minus 28 is 3 weeks slack, meaning that you can delay by 3 weeks for activity E without affecting entire time duration of 38. That's the project we have, which indicate that this is a fairly difficult project to manage because we have only one slack time and all other activities should be done on time in order not to delay the project. Okay, thank you.